Friends, this is chapter number 11 of grade 10th, The Human Eye and the Colourful World. The first topic that we have to do from this chapter is refraction of light through a prism. The refraction topic we have already learned in chapter number 10. The transfer of light from one medium to another medium allows the bending of light. This bending of light is known as refraction of light. Now we will be doing an activity in which we have to take a white paper and you have to place it on a whiteboard, and on top of it you have to keep a prism and mark the triangular region face of the prism. There is a triangle ABC will be marked. Now draw an angle of 60 degree on one side of the prism with the help of a scale and a protractor. Place two pins at the positions P and Q. Keep the prism again. Try to see the image of the pins P and Q. You will see the image of the prism P and Q at point R and S respectively. Plot the points R and S, draw the line PQ and draw the line RS. Now here you will get an image rays like this. PE is the incident ray, EF is a refracted ray, Fs is the emergent ray, angle A is the angle of the prism, I is the angle of incidence, R is the angle of refraction, E is the angle of emergence, D is the angle of deviation. This is the refraction of light through a triangular glass prism. Now a prism is a pyramidal piece of glass with two triangular bases and three rectangular lateral surfaces. The angle of the prism is between the two adjoining lateral surfaces. The angle of deviation is the angle between the incident ray and the emergent ray. When white light is passed through a glass prism, it splits into 7 constituent colors, which is known as the spectrum or dispersion or band of 7 colors. This phenomenon of white light to spread or to split into 7 colors is called dispersion. Spectrum is the band of 7 colors formed due to the dispersion of white light. Now this spectrum is represented by a sequential of colors known as Vibgyor. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. The angle of deviation is inversely proportional to the wavelength. Red is the least deviated color as it has longest wavelength, and violet is the most deviated color as it has the smallest wavelength. So Isaac Newton was the first person who proved that sunlight is made up of 7 colors. He passed sunlight through a glass prism to form a band of 7 colors. Now he tried to split the colors further by putting another prism ahead of the prism, forming spectrum, but he failed to obtain more colors. He found a spectrum from sunlight and placed an identical but inverted prism in front of the prism, forming the spectrum. Now all the 7 colors combined by the inverted prism and emerged as the white light. Now this is because of total internal reflection. When light enters obliquely from a denser to a rarer medium and the angle of incidence exceeds the critical angle, this angle light reflects in the denser medium. This is called internal reflection. Now the conditions for internal reflections are light should be never enter obliquely from a point. Now this is a rainbow of sky. So how can you see the rainbow? Rainbow is a natural spectrum that appears in the sky after the rain. It is also caused by the same principle, that is dispersion of sunlight by tiny water droplets that is present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets in the atmosphere acts as a small prisms. They will refract and disperse the incident sunlight, then reflect it internally and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. So we can see a rainbow on a sunny day when we look at the sky through a waterfall or through a water fountain. Now next is the atmospheric refraction. Atmospheric refraction, we have seen that apparent or random wavering or flickering of objects, twinkling of the stars, the hot air rising above a fire or a radiator. The air just above the fire becomes hotter than the air further up. The hotter air is lighter than the cooler air. Such physical conditions of the refracting medium are not stationary. The apparent position of the object as seen through the hot air fluctuates. This wavering is thus an effect of atmospheric refraction. On a small scale in our local environment, the twinkling of star is a similar phenomena, and it is also due to the atmospheric refraction. The stars twinkle due to the atmospheric refraction of starlight. The starlight, that is the light of the star, enters the light of the star the light of the stars enters the atmosphere, undergoes a refraction before it reaches the earth. The atmospheric refraction gradually changes its refractive index. Now, because of this, atmosphere bends starlight towards the normal. The apparent position of the star is slightly different from its actual position. The star appears slightly above that its actual position when viewed near the horizon. Further, this position of the star is not stationary but keeps on changing slightly. Since the physical conditions of the Earth's atmosphere are not stationary, the stars are very distinct. They are appropriate point-sized sources of light. As the path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of enters the fluctuates and the amount of light entering the eye flickers. The stars sometimes appear brighter and at some other time fainter, which is a twinkling effect, which is due to the twinkling effect. Now, why do planets don't twinkle? Because planets are much closer to the Earth. If we consider a planet as a collection of large number of point-sized stars as sources of light, the total variation in the amount of light entering our eye from an individual will be point-sized sources will average out to be zero. Thereby, nullifies the effect of twinkling. Nullifies the twinkling effect. Next is the advanced sunrise and delayed sunset. The sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. Actual sunrise means it crosses the horizon by the crosses of horizon. Horizon is a direct perpendicular line from the sun to the observer. Since shows the time difference between the actual sunrise and sunset and the apparent sunset is about 2 minutes. This apparent flattening of the sun's disk is also due to the phenomenon of refraction of light or atmospheric refraction. Now next is the scattering of light. Scattering of light means whenever the light passes through a colloidal object, it scatters the light, and in the colloidal object, the scattering of light can be seen. This is not seen in the solution or a suspension solution. Why is the color of the sky blue? The molecules of the air, the molecules that are present in the air, which are fine particles of the atmosphere, are smaller than the wavelength of the visible light. Now, when the scattering of light is carried out, that is a shorter wavelength at the blue than light of longer wavelength at the red. The red light has a wavelength of about 1.8 times greater than the blue light. So what happens when sunlight passes through the atmosphere? The fine particles in the air scatter the blue color more strongly than the red. The blue color that scatters enters our eyes. On the earth, if the earth had no atmosphere, then there would have been not been any scattering, then the sky would have looked dark. The sky appears dark to passengers who are flying at a higher altitude, as scattering is not prominent at such heights. Thank you.